Okay, so let's say you wanted to build a batch transfer contract. So you want to transfer to multiple people, and you want all of them to receive the stuff, right? Um, like this how are you going to do it, right? So this is what this video is for, and I'm just going to open my terminal and create a new project. So as you can see here, I already created a new project here, and I'm just going to open this in my Visual Studio Code. So yeah, this is the project. So I'm just going to remove this, and now we have the airdrop to move. So the first thing I want to do is declare my module, right? So it's module airdrop, and let's just call this module drop. I'm just going to close that off. Now the first thing I want to do is actually declare an event struct, right? So public struct, and then the name of the struct, right? So let's say airdrop, let's call it airdrop, right? And we have to give it the copy and drop abilities for every event. And then let's just airdrop, or sorry, let's emit the recipient, right? So the recipient is an address, and then once also emit the allocation they got. So allocation is also sorry, it's a 64-bit integer. And now let's just declare the function that actually does the work, right? And so in this case, so let's call this function send airdrop. So it's public fun send airdrop. And now it depends on what you're trying to do, right? So like I said before, every object or everything on Sui is an object, and every object has a type, right? So in this case, we want our airdrop function to be generic, right? So anybody could be able to send any objects through it and any coins pretty much through it, instead of just sending Sui. And then the way we do this is with generics, right? So just going to add a generic type parameter, then give it the store, and then I can now pass in my parameters. So basically I want to pass in a vector, actually two vectors, one vector containing the recipient's addresses, and then the allocations vector, which is the same length as the recipient vector, and for each index of each so basically for the index of the recipient, his allocation is the same index in the allocation vector. And then let's just do that. So in this case, recipient, and then vector recipients actually. So like it's a vector of addresses. So address, and then allocations should be a vector of 64-bit integers. Now the next thing we want to pass in is actually mutable reference to the transaction context. So as usual, I don't know why, but you'd always have to pass this as the last, so don't forget to do that. And that's said, just want to open the function. We're not returning anything, by the way. And now the next thing you want to do is this. You want to always make sure that there is a match between the recipient vector's length and the allocation length. If not, there's a problem, right? So I'm just going to really define a constant for what error it should be. So let's do length error, and then it should be a 64-bit integer, right? And it'll be equal to 404. Let's just say 404 in this instance. And then now we want to get the length of the two vectors, and then assert that they are both equal, right? And so the way we do this is with the length function from the vector, right? So how I'm going to do this is very easy. It's let recipients total be equal to vector length, and then this function takes in the vector, so it refers to the vector actually. So it's like this, and then the recipients. So I'm just going to do the same thing for the allocations. I'm just going to copy this and allocations total. Allocations, and then just allocations here, right? And then now we have the total of both of them. I'm just going to close this off. Now we want to assert that they are both equal, so we're going to use the assert keyword and then open this up, then specify two of them, so recipients total, allocation total. Oh yeah, but this once we specify that these two are equal, right? And then we want to use this error in case they are not equal, so length error. I'll just close this off, and now we can now write the logic that runs when you both of them are equal. Then once now airdrop. So basically, our airdrop utility is going to be a while loop. I mean, and then this while loop is going to run an airdrop to everybody and emit events at the same time, right? So that's actually when we're going to emit these events. That said, let's first define the instance of the index. So basically let I is equal to 0, and then so we want to make this mutable as well, right? So yeah, actually this is supposed to be 0. Yeah, good. Now while loop, we're going to loop through every of the index with this I and then increment it. So it's pretty much as easy as while I is less than the number of recipients or the number of the allocation, let's just use one of them, right? Then what we want to do is we want to borrow the amount and then borrow the recipients from the vectors and then do what we want to do, right? It's actually going to be a reference, so we have to like borrow it, right? We do not want to keep the allocations or anything in the scope. So that said, let's just really do it. So just let the specific amounts in that index, right, be equal to then vector borrow. So we want to borrow the vector in this case and then specify the index here. So we already specify the index here and it's already I. What we have to just do is borrow the vector, and for this since this is an amount, we want to borrow from this allocations vector. So I'm just going to copy it, paste it here, and then reference it, right? And then I'm just going to do the same thing for the recipient addresses. So address, let's call this address, right? Addresses, actually call it addresses. I'm trying to like not duplicate any naming, and so let addresses, okay, and then just change this one over here to recipients, right? And now the next thing we want to do is now send the type or the coin pretty much to the recipient, right? And then here's the thing: what if the person passes in the entire balance and we wanted to split? So let's say now I'm just thinking, so let's say you created a new coin and then the entire coin is one object and in one balance. So in some cases you now want to like split it so that everybody could get their own portion. So something like it's very useful at TGE. So let's just usually do portion. So let's split for each recipient, right? So the portion is equal to coin, right? And I have to import this. So this is like the coin for working with coins, and then so split, right? And then I have to import this, by the way, but this is supposed to be the coin. So I'm actually supposed to specify the coin as well because we didn't do that before, and the person is actually supposed to pass in the coin. So I'm just going to specify it before this, and the coin is going to be a generic type parameter as well. So let coin, and then the reference to the coin object. So I'm just going to do this, right? And now I just gotta import this at once. So it's use Sui, yeah, and coin, and I'm just going to import self and coin. So that way we no longer have those errors anymore, right? So now I missed the comma here, and then the next thing we want to do, I now specify the coin. So the next thing I want to specify is actually the amount. So in this case, the amount we want to split is this amount here, right? And then we have to specify the transaction context, right? Just ignore this error for now. It's actually an error to check, like are we really using all the resources, right? and then something that we're going to eventually do. So it's not something you have to worry about. So now let's transfer these portions to the person that we're supposed to transfer it at the moment. So it's transfer the public transfer, and then the object wants to send this time is portion. So that the portion of that coin wants to send it to the address that we just called addresses, right? And now that works. So basically, to go over this again, we first look through each index and then split a part of the coin and then send it to them, right? So the next thing we want to do is emit the event. So in this case, we want to use events, the emit, the events we want to emit pretty much. So it's airdrop. Our event is called airdropped. So yeah, I'm just going to allow this to fill in for me, and yeah. So I also have to import this event. So it's use Sui events and then emit, right? Or we could actually just emit this and then use events and emit here. So we already did events and emit, and now the recipient and the allocation, right? So in this case, the recipient is the addresses variable, and then the allocation is the amount. Yeah, so as you can see now, we don't have any errors and everything works, right? Then the next thing we definitely have to do is to increment the index. So it's that's actually why we made the I variable mutable. So I plus 1, and then close that off, right? We'll to close this off, and now everything works, right? Yeah, so actually it's supposed to be inside the loop, right? So now everything works and we can now build our program. So just for checks, we could easily build. So just going to run Sui Move build, and that runs and it gives us some errors. Also from warnings. The warnings are that we didn't use the splits that we imported, and then we didn't use the amounts that we imported, and I think these are like imported by VS Code, so we didn't import that explicitly, probably. So I'm just going to remove those two, and then those warnings should be gone if we run this again. Sui Move build. So yeah, everything works, and you can now publish this and then interact with this over CLI.